So thank you for coming to this talk today. One of the things that's interesting in the Java right now is the number of languages that are being that you can run on the JVM. If some of you went to the keynote speak yesterday, you may have heard Jason McGee talk about Java and the future of Java, and he specifically said that one of the important things about where Java is going is that we need to be looking at putting more and more languages or supporting more languages or scripting languages on the JVM. And what's clear is that, yes, Java can provide a lot of solutions to many problems, but it's not going to provide solutions for everything, and that's where scripting languages can come into it. Hence this talk. So a little bit about me. So my name is Porthwaite, and I work at IBM in Hursley, in the United Kingdom. I've been working in Java for over 11 years, and primarily I've been working in the quality assurance team. Recently, my role is the quality assurance Java 8 test lead, and I coordinate testing across various continents where we have test teams. One of my recent focuses is working in the OpenJDK community, where we need more tests in the community so that we can ensure that the OpenJDK is of sufficient quality. So, what are you going to get from this talk? I'll be giving an introduction as to why me and what it is that I do in my day job. I'll be talking about why we run scripting languages on the JVM. There are different ways of embedding Java embedding scripting languages within Java, and there are various models of doing so too. And then I've chosen two frameworks where I'll be comparing and contrasting two frameworks in how you can embed Java. And then we can talk about what we think is the best approach. So my team and our job is to break Java. In IBM, we test many SDKs. We have 18 platforms that we support. And if you look at the number of operating systems that are available on those platforms, we have a big job ahead of us. And one of the things that we focus on is the system test side of quality assurance. So the unit testing, FE testing has already been done and is being done in parallel to system test. So what do I mean by system test? There could be a whole presentation on system tests, so I only have 2 minutes to talk about it. So I've narrowed it down to two things. One of the interesting things about Java is the JIT. And when you look at JIT defects across different platforms, we find that load-level testing, so we're stressing the JVM, to the point where we're trying to break the JIT, we're trying to break the VM. And I find that with multi-threaded stress tests run for 5, 10, 3 hours, 60 hours, helps stress the JVM and find bugs so that when IBM delivers an SDK, it's a good quality. And then there's third-party applications. There are endless number of applications out there that are open source, and these applications is what you, IBM's customers, use. So we need to make sure that those applications work, so when IBM ships its Java, on day one, those applications are good. So where does this fit into scripting languages? Scripting languages over the last many years have become very popular, and we need to make sure that those languages work on the SDK. So that's what we did. So the reason for this talk is because we've been testing scripting languages on the IBM SDK. So I'll ask you a rhetorical question. How many languages run on the JVM? I did some Google searches and I found that if you go back to Java 1, when Java version 1, there's probably over 800 languages that currently run or have run on the JVM. If you ask Wikipedia, that typically narrows it down to about 60 which are currently active. So that's quite a lot. Now, it's very hard to narrow down which languages I should put on the next slide because there are so many of them and we all have our own favourite language. So forgive me if the languages I'm going to show are not the languages that you've used. But typically, we find that these languages are popular in terms of running on the JVM right now. And they all have different benefits, and they're all there for different reasons, and we all use them for different reasons. In this presentation, I'll be going through some code snippets using code from these languages when we compare and contrast the frameworks that you can use to embed Java. Before we do that, we need to understand, well, why are we running Java? Why are we running Java? Why are we running scripting languages in the JVM? Why is the JVM really that popular? At the keynote yesterday, it was clear to me that performance is one of the important things about Java. The JVM is fast. The runtime performance benefits that you get with running scripting languages on Java are really important, and that's one of the reasons why we do it. You also get the threading support and scalability that Java brings to the platform that you're running on. One of the other things that the JVM brings is the RAS and the profile tooling that you get, so you can profile your Java application and make it run better. And all these tools are free as part of the JVM, so that's why it's so useful to be using the JVM to run your scripting language. And if you look at the array of APIs that are currently available to a Java programmer, it's amazing that if you think you can use some or all of those APIs within your language, and we'll go into that a little bit later. And then finally, the support for multiple languages is there right now. So which is one of the reasons I think we're using it. So let's have a look at some of the implementation methods that we currently have available at the moment. Some languages compile to bytecodes. So we compile to bytecodes because that's when we get the performance. That's when we get the performance with compiling to bytecodes. And these three languages here are examples of doing that. In particular, Jython, which I have an example with in a minute. And then we have languages which are interpreted on the JVM. I should point out here that, again, I'm only limiting the presentation to a number of languages. There are many more that fit into these categories. I'm only limiting it to a few, otherwise the chart would be extremely busy. What we mean by interpreted on the JVM is that the language has provided a Java interpreter, and you're effectively running your script on that interpreter on the JVM. And then we have embedded, and what we mean by embedded here is that you're effectively embedding your script in your Java application on the JVM. And all these languages support that, which is what we're going to be going into. So a little bit more detail of what we mean by compiled to bytecode. In this example here, we're taking a Jython script, and we're putting it through Jython C. Under the covers in Jython C, what it's doing is doing two things. It's converting the Python script to in this case, it would be mypythonapp.java, so it effectively creates a Java file, and then it puts it through Java C compiler, and at the end you get a class file. And then, like anything you can do, like in most cases with Java, you can then just run that on the JVM. Interpreting on the JVM is where you have where the implementation, the language implementation has provided a interpreter. So in this case, JRuby has an interpreter which you can run on the JVM, and all you're doing is just passing in your script into that, and then it'll run. Embedding, which is essentially what this talk is about, is a little bit different because you have your Java app running on your VM, and there's this concept of an engine, which is what I'll be mentioning a lot now. An engine effectively is your access to your scripting language, and we create an engine, and then we do things with that engine in order to run and interoperate with the scripting, with the scripting language that you have inside that engine. So in this example here, we have our Java app, and we're reading in our script, and we're using that script to invoke our engine, which effectively means we are embedding the script in our Java app. To prove the point that one of the things that we can do, in terms of use cases, it's arguable as to whether you'd want to do this or not, but the point is you can, if you wanted to, take one JVM and you can have multiple scripts from different languages running on the JVM. And that's the reason for this slide, is just to make it clear that we can run multiple versions of Java. Multiple versions of scripting languages. So what models are available when we're talking about scripting on the JVM? There are three models, which I'm going to go into a little bit more detail about what we mean by scripting. And the first one is where the domain knowledge, the knowledge of the developer is in the script domain. In this example, what we're doing here is that we are creating Java objects within our script. So there's no reason, looking at the code snippet here, why this is a JRuby code snippet, that if we wanted to, we can use our JRuby script, and we can, the top line is require Java, so effectively we're saying, give me access to Java, and then we can create Java objects, and we can put things on the screen if we wanted to. So there's certainly power there if you wanted to do that. In terms of knowledge, you do need to understand the scripting language, so you've already chosen your scripting language, because you will then need to understand how you go and implement, or how you go and embed Java objects within your script. There's the biggest problem we have with this is that the reuse capabilities are very small. That's because you are spending time understanding the scripting language specifically on how, in order to be able to embed Java objects. Each language will do it differently, because that's how the language does it. That's based on the script, on the syntax of that language. So you are kind of locked into using that scripting language. It's still a valid thing to do, and people do it because they want to access the Java APIs from their language. So in this example, which is where the domain knowledge is now Java, and we have we can run a script which is embedded within a Java application. The API to do that is provided by the language. So for example, with JRuby, you can go and you can download the JRuby Embed, core Embed API, which will allow you to run your scripting language on the JVM. Again, Java knowledge is required because you need to understand, that is the main thing here. You need to be able to implement the scripting containers. You need to understand how to do that. And also, you'll also need to know how the language-specific API works. On this slide, I have a bridge here, and what I mean by bridge is that if you consider a scenario where you have legacy scripts that do a particular function, and you want to run those scripts from your Java application, then maybe more appropriate to wrap that with a wrapper or a bridge so that you can only, so it makes it a lot easier. The downside of doing that is that as soon as you've done that, you're then supporting the bridge as well as the script. Finally, we have this is the most interesting one of all in the models, because we're talking here about having Java and script talk between each other. So here we can invoke a script from a Java application, and we can create and use Java objects inside the script as well. In this code snippet here, what we're using is JSR223, which is, I'll be mentioning that very soon. And with JSR223, that provides a common API to run your scripting languages on the JVM. You would still need to have knowledge of that API in order to do this, and you'll also need Java knowledge as well. Depending on what it is that you're doing, you will also need scripting language knowledge, but again, it depends on what those scripts you have, whether you're writing scripts from scratch or whether you already have some legacy scripts. The important thing about this particular model is that you can support multiple languages, because JSR223 will allow you to do that. So what do we mean by embedding? It's not particularly clear what we mean by embedding. So going back to our previous example of where we have multiple scripts running on a JVM, this is embedding a script or more than one script in an engine, which then runs, and you can interoperate with that particular engine. So embedding, what you can do is you can run a script. You can say to the engine, I want an engine with this particular feature, say JavaScript, and here's my script, go and run it. Where it gets powerful is that you can actually pass variables to the script, and you can return their value. So all of a sudden, this is where it gets exciting, because you can have your script which performs a function which you want to keep separate from your Java application. Be it some logic that maybe a customer keeps up to date, and you just have your Java application. And all of a sudden, you can then separate that out by having your Java application run the script. And that script could be managed by anybody, be it a customer or somebody else in your team. The other thing you can do is you can call a function within your script. So I have some examples of doing that. And the advantage of that is that you can run, your Java application can call out to the script to do something specific. I have an example where it works out a square root of a number, but in real life, a bit more complicated than that. And you can run multiple scripts on the same JVM, which I've mentioned already. And finally, and this is an interesting part of embedding, is that you can run your script relatively easily on JVM. But one thing that you may need is you may want to take advantage of the power that the particular language provides. And you do that by configuring the environment. But it's not always easy to do that. And that's what we'll talk about. So ways to embed a scripting language on the JVM. I've identified two here. We have JSR223, which is JavaX.script API. And we have a language-specific embed implementation. So already, previously, we've seen the JRuby implementation, which allows you to embed your scripts within Java. Looking at just JSR223 for a moment, it is a common API, and it's available for multiple languages. The languages that I've shown you already do provide a support for JSR223. And the point here is that JRuby has physically gone on, created an implementation for JSR223, which allows you to effectively, and I'll talk about JSR223 in a second, Language-specific APIs is very similar to 223, but the main difference is that they provide language specifics, and it allows you to fine-tune the engine that you're running. It allows you to take advantage of the JRuby language, for example, and you can't easily do that with JSR 223. And again, of the languages I've looked at, both of them provided 223 implementation and their own Embed implementation as well. The talk will now go and look at these two frameworks, and I'm going to provide some code examples on how to do that. I'm going to introduce JavaX.script, and I'm going to be using JRuby, Jython, and Groovy languages to provide examples on how to do this. Just for your information, I have removed some exception handling from the slides because they get a bit too busy when you've got too much code on there, and I want you to be able to read it. But if you're using any of the IDEs, NetBeans or Eclipse, it'd be very obvious that you need to include these. So what is JavaX.script? Why is it there, and why do we use it? So JSR 223 was first delivered in Java 6 SE, so it's in the Oracle's build now, it's in IBM's build, IBM's Java rather. And effectively, it allows the developer to embed a scripting language in a Java application. The specification defines 6 interfaces, and we'll be touching on some of these later. What's important here is that the bottom 2, invocable and compilable, are actually optional interfaces. And this is actually quite important when you're considering which framework to use, because you may need to use those interfaces and your language may not provide it. How you set up JSR 223 is reasonably easy. You identify the language or languages that you want to implement on Java, Embed rather. You download the relevant jars for that, add it to the class path, and where your scripts exist on your computer, you just need to add that directory to the class path as well. The way the script engine works is that at runtime, the jar services mechanism is invoked, and that allows us to determine which languages we have installed. In this example here, we are querying the script engines to find out what we have installed. So we are using Script Engine Manager. So I'll just start from the back. So we're importing JavaX.script, which is the API. We're creating a Script Engine Manager object. And on that object, we're asking it, give me all the engines that you've got. And once I've got that with the engine, with the scripting engine factory, I then go through them all and I'm listing the versions. So if you can see at the bottom of the slide, when I did this, I had Groovy scripting engine installed, I had Jython, and I had JRuby. Rhino, which is JavaScript, is installed by default, and that's what Oracle provide. So that's always there. In this example, we're using JRuby, and in the next couple of slides, I'm providing a JRuby example, a JSR 223 example, and I'm comparing that to the equivalent that would be available with JRuby's implementation. So again, we're creating a scripting engine manager, and this time what we're doing with that is we're saying, okay, I've got the manager now. I want an engine that's called JRuby. So as you can see, the abstraction is completely abstracted. It just says, give me an engine, give me an engine which has JRuby. If the JRuby engine is not installed, an exception would be thrown. We then have to read in the script, and once we've done that, the engine.eval, so the eval method of the of engine class, will effectively allow us to invoke the script. So eval is evaluate and go and run my script. So as soon as you call engine.eval, that script will get run. And whatever that script does, it will get run. Compare this to JRuby's implementation. You could argue that it's simpler because all we're doing here is we're creating a scripting container and we're running the run scriptlet method. And again, it'll just go and run it. Now, this is fine. You can run a script, but that's okay. But it's not particularly that exciting. So what else can we do? We can pass a variable to the script, and we can retrieve it back again. So we do the same thing again. We create a scripting manager. We get our engine, and this time we're using the put method of the engine. So the way this works is that when you have an engine, when you have a scripting engine, that effectively defines your script. So if you are adding a variable, or rather putting a variable into your script, you use the put method. So essentially what happens is that you're adding the variable to the engine. You're then running your script using the eval method, and then we're using the get method to get the variable back again from the script. And you can see that in the example bottom right, where we've got Jython output, Java output. Similarly, you can use the Jython Embed API, which is called Python interpreter. And here we call in the exec file, which allows us to. Sorry, I'll go back 1 second. We're creating a Python interpreter, and we're calling the set method of the Python interpreter to create a string, Java string, and giving it the value red, green, and blue. We're then invoking the script, and then we're calling the get method of the Python interpreter to give us the contents of that string back. So this is very simple, and it can be quite powerful depending on what it is that you want to do. Here we're using Groovy, and we are invoking a function. So again, the same code at the top for JSR 223. You have that always. I'm asking for Jython engine, and I mentioned before that of the 6 interfaces that JSR 223 provides, 2 of those interfaces are not mandatory. So the implementation, say JRuby, does not have to implement those 2 interfaces. And that can be problematic because you then have to go and have to program your application to take that into consideration. So here I have to check that the engine is an instance of Invocable before I can even use it. This is actually one of the limitations of 223, which I'll get into, because you're now changing your Java logic to make sure that you've got that implementation of Invocable. So anyway, we have one. So JRuby does provide an implementation of Invocable. And what Invocable lets us do is that we're reading, in this case, we read the script, and we call the function invoke function. So the function is called square root, and I'm passing it the value 360. So the script will then run. So in the bottom left-hand corner, you can see the script, and you can see that we have defined a function called square root, and all that's doing is receiving a number as an argument, and it's running the math.squareroot function, which is a JRuby function. My apologies, a Groovy function. So as you can see, the invoke function, it's fairly easy. You can go and do some work for me and give me some data back, and then your Java application can then do something with that data. And just to make things, just to give you the Groovy Embed API also allows you to do this. And here we're creating a Groovy script engine, and we're getting a Groovy object. And then when we are calling the invoke method, passing square root and also passing the number 360. So there's two easy ways of being able to call a function within a script. Now, this is great. This is really good. But what if you wanted to tune your engine? What if you wanted to take advantage of your script engine, of JRuby's implementation, the power that JRuby provides, for example? How would you do that using 223? And this is where 223 falls apart to some extent, because you have to understand your specific script engine and what it is you want how to do things. So, for example, here I'm creating. If I want my JRuby engine to be thread safe, I have to set a system property, which is not ideal because once you've set that system property, it becomes available to any other engine that you want to create. I also may want to set JIT verbose logging for my JRuby, and I'll do that. Now, as you can see, that the value that I'm setting is jruby.jit login verbose. How would I know that? The only way I'd know that is by going to the API docs for JRuby to find out. So as soon as I want to configure my script engine using JSR 223, I am therefore moving away from what 223 provides and looking at what the script engine can do. Although it's just not ideal because you don't know how to do it, you have to go and find out. And finally, you can set the JRuby path. So using the thread safe example taken a little bit further, here we have the JRuby Embed core API, and all we do to create a thread safe environment for JRuby is we're just passing in the thread safe in our constructor, and that's all we're doing, and then we've got an engine which is then thread safe. And similarly, as I've already said, we have to set a system property, so it isn't particularly ideal. So it is well documented and easy to find. JRuby's Embed Core API. It's clearly listed of what things you can and cannot do with the engine, and it provides a very clear table of this is how you do it in 223. This is how you do it with JRuby's specific API. JavaX script is set system-wide. The multiple engines will have the same behavior, and it's harder to find documentation typically because not all the documentation is as good as JRuby's. Comparison, in this example, we're looking at a Groovy, and we are looking at the setting the compiler warning level. The point of this example is that it's easy to do using Groovy's implementation, but it's not easy to do at all using JSR 223. I haven't found a way to do it. So all of a sudden you notice this is where the two frameworks diverge. How far does JavaX script go? I think it's great. I've played with it and I quite like it. I like the fact that everything's abstracted from you. It's easy to use. You can plug and play language support, multiple languages. It is brilliant for embedding, and it's a great API, very easy to use. But it is a bit basic. And it's great if you don't have a scripting language already chosen, or you don't have any legacy scripts, because you can just go and create them and use it. But the limitations of JSR 223 JavaX.script, I've already mentioned that the two interfaces, invocable and compilable, are not mandatory, which means that you have to change your logic within your Java application to test for these, which I don't think is particularly ideal. And when you're setting language-specific options, the abstraction just kind of disappears a little bit because you then have to make your Java application specific to that language. And as I said just a second ago, how JRuby implements option settings is different to Groovy, for example. So you would have to go and investigate these options language by language. So I think that running scripting on the JVM, I think, is brilliant. I like it. It's good. It's fun, and there's certainly going to be a lot of innovation, I think, in this area over the next couple of years. Given the fact that most languages support it, I haven't found one yet that hasn't, though I haven't gone through all 60 of them, to be fair. It's clear that the languages want to support 223. So the API is still very useful. I think the way to look at it is that if you're starting from scratch, JSR 223 could be useful if you want to do some basic embedding. But if you want to leverage the power of your language that you're using, then 223 falls apart because you just don't have the flexibility to fine-tune your engine. So as an IBM, as a tester, one of the things that I'm particularly interested in is how IBM's customers, how you use Java, and more specifically, how you embed your language within Java. So this is the end of the talk. I would love, it'd be great if you could, if anybody want to share your experiences with embedding in Java and how you do it, because one of the things that we want to do in my team is improve the testing that we do. And I can only do that if I understand more about how Java is used and how you use these APIs. So thank you for listening. I just wanted to say that quickly that later on this evening, for those who are interested in testing, and specifically OpenJDK, a colleague and I are running a BOF with Oracle on testing with OpenJDK, and that's today at 7:30. So if you're free, please come along and get involved. I'm available for questions and answers if anybody wants to ask anything. Thank you.